the change of the volume is equal to S2 minus S1 times A. You can see that when we measure S1 and S2, S1 is the displacement of this phase of the element. Okay, so this is S1. So S1 represents the compression of this element, okay, because this displacement is the compression of this element. S2 is measured from this phase, okay, of this element, from this phase. This is S2. So you can see that S2 represents the expansion. It represents the expansion of this element. So if S1 is larger than if S2 is larger than S1, this element expands. But if S2 is smaller than S1, this element compressed. So in this figure, we can see that this element is compressed, and it's obvious that S2 is less than S1. Okay. And from this expression, we can have that delta P is equal to the minus of B delta V over Vi, and is equal to minus of B. Here delta V is A delta S, and Vi is A delta X. So A cancel, and we have that this equal to the minus of B delta S over delta X. If we take the limit of delta X go to 0, we have that the delta P will become the minus B of ds by dx. Okay, we have the partial derivative here because s depends not only on x but also on t. So this is just the change of the delta s as with respect to x, so that we have to write down this as a partial derivative. Okay, and now as I mentioned that if we want to write down the pressure wave like this, we have to change the form of S a little bit. So I will change the form of S here. X as a function, S as a function of x and t is equal to S max cos, change from sine function to cosine function, but it still have the same meaning as we discussed this many times, that sine and cosine function are both sinusoidal function. So we can use both to represent the oscillation, but we use this form of S here to get this form of P. So you can see that now delta P is equal to the partial derivative of this function s, so it will become B S max K of sine kx minus omega t. Okay, and this B sine B S max K is the delta P max. So if we use delta P max is equal to the B S max K, we will have the wave function of the pressure wave. Okay, delta P is equal to the delta P max sine kx minus omega t. Okay, so that is the mathematical description of the sound wave in terms of the pressure wave.